Okay, student notes 5.7 double angle properties. If you don't have your formula sheet out, I would encourage you to go ahead and get that out because we're going to refer back to those properties and you don't have to have them memorized. So for these notes, for this video lesson, we're just going to do three proofs. And on some of these, I'm going to do them in more than one way. Okay, so let's first just look at problem number 1. Okay, so when you're doing a proof, remember that you always want to write the side you start with, and you want to decide which side to start with. Okay, so it looks like these two sides don't have anything in common. So let's just go to the good old standby, which is start with the more complicated side. So let's go ahead and start with the side that says 2 tan x divided by 1 plus tangent squared x. Now this looks familiar to me, so I'm going to go ahead and look at the formula sheet. And it looks a lot like this formula, but this wouldn't really be, I don't want to prove that it's equal to tan 2x anyway, so it's okay that it's not this exact thing. It's good that that maybe looked familiar, but it doesn't help us. If I, scroll back up, let's see if anything else on there is something that looks familiar. So it kind of looks like the sum and product, or sum and difference. I'm gonna have to pull it up this way. But if I go up even a little bit further, I can see that 1 plus tangent squared is secant squared. And this may be something you would have forgotten, and it's something that you should already know, but again, it kind of, with all the new identities, maybe the Pythagorean identities get lost a little bit, forgotten. So let's make that substitution, because at least with that, then I no longer have a binomial in the denominator. Okay, so you may be asking, well, how on earth would I know to do that? Well, there's not much else I can do. Conjugates don't work with something like this. It would work if this had been 1 plus tan x, but since it's 1 plus tan squared, multiplying by the conjugate wouldn't do what I want it to do in that case. And Pythagorean identity does do something. It makes it to where I don't have pluses and minuses anymore. Now I just have a single term that I should hopefully be able to simplify. Okay? So then we want to look at another way to rewrite this. Now I'm going to just rewrite this as 2 tan x and then write secant squared as cosine squared. Now I don't even have a fraction anymore, and if somehow I can simplify this and work my way to sine 2x, then that would be the best. Okay, so remember that tangent of x is sine x over cosine x. And remember that cosine squared, we could maybe write this as cosine x times cosine x. Now, one of these cosines is going to cancel with the denominator. If you want to think of it like this, these are over 1s. Now look at what we have left. We have 2 sine x cosine x. That is the double angle formula for sine of 2x. Therefore, we proved what we were trying to prove. Okay. This is not easy to see. These proofs don't get, the first time you see a proof, it is difficult. And so we just kind of have to get over that, and then we have to keep trying and practicing at them. Okay. So let's look at the next one. Okay, I'm going to switch back to red. I don't know why I switched to blue. Okay, so let's look at problem 2. Again, just looking at the two things, right-hand side looks more complicated. So I'm going to start by writing that secant squared x all over 2 minus secant squared x. This is another case where using I wouldn't want to multiply by the conjugate of the denominator. because of the squared. So I need to think outside of that. Okay. Next off, I don't really have a identity that's just like 2 minus secant squared. I can maybe use a 1, but then I'm going to still have an extra 1. So let's think of something else that we could do. Okay. What I could do is I could replace the secant squared with the cosine squared down here. Now let me show you what happens now. Okay, now if I were to multiply through that cosine squared, and I don't have anything in the numerator but a 1, and you got to put the 1 there, but when I multiply through now, I have 2 cosine squared x minus cosine times secant, both squareds. Alright, now I'm going to go ahead and write this out. Although when you were writing this out, you could go ahead and call this a 1 because they're reciprocals, and the fact that they're both squared, it leads to a 1 squared, which is still just a 1. Now, let's think about what this is in the denominator. 2 cosine squared minus 1. Look on your blue identity sheet. That is cosine 2x. Okay, so I'm going to scroll back down here, back to the back. So this is cosine 2x. And what is the reciprocal of cosine? Secant. So this is equivalent to secant of 2x. There you go. You proved what you were trying to prove. Okay, now I'm going to work this proof a slightly different way. That maybe for some of you this is the way you would have seen this to start off with. Okay, so we proved it. Now I'm going to prove it a different way. If I have secant squared x divided by 2 minus secant squared x, some of you might have been thinking about Pythagorean identity. Okay, so some of you might have been thinking with the secant squared that you could replace that with 1 plus tangent squared. And you can. This would be, to me, this is kind of difficult to see why this would help you. But let's just go ahead and see how this plays out. And then you would do the same thing in the denominator. 2 minus, and I'm going to go ahead and put this in parentheses, 1 plus tangent squared x again. Okay, so now let's think about what we have. Okay, I have a 1 plus tangent squared in the numerator. And then if I distribute here, 2 minus 1 minus tangent squared, this would become 1 minus tangent squared x. Okay, so now I'm kind of at a place to where this is still not getting me where I want. But let's see if we can work on getting a common denominator of the numerator, then a common denominator of the denominator. You're going to find that what I'm working here is many more steps, but I'm just working this out to show you a different way to solve it. If I change this to be sine squared x over cosine squared x, in the denominator I would have something very similar. Okay, now let's think about the common denominator would be cosine squared, so this would be a cosine squared x, okay, over cosine squared. So this would give me cosine squared x plus sine squared all over cosine squared. Okay, and in the denominator I would have something very similar. This would be cosine squared x minus sine squared x over cosine squared. Okay, now I'm going to have to, this is a longer proof like I told you. This would be the same as cosine squared x. I feel like I'm just going to run out of room. I'm going to have to start writing a little bit smaller. So this would be the same as cosine squared x plus sine squared x over cosine squared x times the reciprocal of the denominator. So here the cosine squared x would go in the numerator, and in the denominator I would have cosine squared x minus sine squared x. Now I'm going to go ahead and show that these cancel. We've seen this many times in problems like the tangent problems, but we've seen that, you know, this is a term times cosine, this is cosine times a term, so we can do that. Now, cosine squared plus sine squared, that's a 1. Cosine, so this is what we're left with. And what is cosine squared x minus sine squared x? It is the double angle formula for cosine 2x as well, which is secant of 2x. Now, what I find is that a lot of students will want to do things like this, which is, I'm showing it to you. It's much more elegant to use this, but it kind of took a little bit of clever thinking and thinking a couple of steps ahead. All right, let's look at the last one. Okay, so looking at this, wanting to start on the right-hand side, so let me rewrite that. It's going to give you tan x cosecant squared x, and then all of this over 2. So let's just replace these with what they are. So tan x is the same as sine x over cosine x, okay? And then I'm going to go ahead and write a times. Cosecant squared x is like 1 over sine squared x. And then the over 2, instead of writing this all over 2, keep in mind that this is just times 1/2, or I could have even put the 2 in front. But don't make fractions into fractions, and just keep it as one simple fraction if you can. Now, I can cancel that sign with one of these, okay? And the whole numerator now is just 1, and in the denominator I have a 2, I have a sine x, and I have a cosine x, and I've written it in this order so that it's really obvious which formula we're going to use. And that's going to be, this is the double angle identity of sine 2x. So I'm going to write that 1 over sine 2x, which is equivalent to cosecant of 2x because sine and cosecant are reciprocals. So we proved what we needed to prove. Now this is a case where it wouldn't have been too bad to start from the other side. Okay, so if you feel comfortable with the lesson and you want to cut it off now, do that. If you want to see maybe how this could have been solved a different way, then keep watching. So here we have cosecant of 2x. If I had started with this side, I would have immediately said this is the same thing as 1 over sine of 2x, okay, which if I use the only formula we have for sine of 2x, that would be 2 sine x cosine x. And then thinking about how I could get what I want on the other side, I know that I need a sine x in the numerator, okay? So what I could have done here is I could have multiplied by sine x over sine x. And by doing so, okay, I'm going to keep the 2 in the denominator. One of the sines over cosine would have become tangent. The sine x times the sine x in the denominator. Let me just go ahead and write this in as an intermediate step just to make sure it's clear. Sine squared in the denominator would be the same as cosecant squared in the numerator. And I will say this again in class, you may look at this and find a different way to prove it using all good strategies that you really think is easier, and for you it is. Okay, I'm not going to work out every proof all the different ways. I feel like we're at the point now where I can work them out maybe 1 or 2 ways, but there are still many more ways to work out most of these proofs, and so that's fine, okay? Bring your questions to class.